In this project we have made a NOT, AND, OR, and also an AND gates using breadboards. So we used transistors, resistors, switches, LEDs, power supply, and wires. First we built NOT gate. So basically it uses a single transistor. The input is connected to the base of the transistor through the resistor. And the LED is connected to the collector side, and it is powered by 5 volts power supply. So when the switch is turned off, there is no flow into the base, and the transistor remains turned off. And the flow travels to the LED. And as a result, the LED turns on. And so when the switch is turned on, the flow flows into the base of the transistors, and therefore it turns it on. And so the flow travels to the ground basically instead of the LED. So as a result, LED is turned off. Next we build the AND gate. It works similarly to the NOT gate. However, this time we use 2 input switches instead of 1. So basically the circuit uses 2 input switches and multiple transistors. They are arranged in a way that both inputs, basically both switches, must be activated for the circuit for the LED to turn on. Each input controls the transistor through a base resistor, and the transistors are connected in a way that the current can only reach the output stage when both transistors are conducted. So basically it won't work, the LED won't turn on if only one switch is pressed, and therefore since the path is incomplete. And when both switches are turned on, the LED turns on, otherwise it remains off. Next we built the OR gate. It was slightly more complicated. We used 3 transistors, 2 base resistors, and 1 extra resistor, LED, 2 switches and inputs, and again 5 watt power supply. So first of all, 2 switches, they represent 2 inputs, and both of them connect through a resistor to the base of the transistor. So these 2 transistors, they act as the detection of the input. So they detect when we press the buttons. So when the switch is off, there is no current, and when the switch is on, there is current, and the transistor turns on. So basically, the way the OR action happens is that even if one transistor conducts, it is enough to drive to the flow of current to the next stage. So you don't need both switches to be turned on for the flow to pass. Basically, when that's the case, it creates the OR logic for the gate. Also, as a part of the bonus, we have created an AND gate with the help of the other group. So basically we connected our AND gate to a NOT gate from other group, and it works because an AND is just simply the inverted output of AND and combination with the NOT gate. And it successfully provided the correct AND table. Basically, it worked correctly. And that's basically it, what we have done in this project.